fencing, spotters, debris trucks, crushers, magnets, and sorting equipment. Those choices are not decorative. They decide whether controlled demolition feels calm, predictable, and useful when real people use it under pressure. One useful way to understand this chapter is to picture a high-reach excavator nibbling from the top down so the machine never sits under the falling structure. That moment looks ordinary, but it is carrying timing, geometry, materials, controls, maintenance, and human expectation. The engineer is not trying to make one part impressive. The engineer is trying to make many small decisions agree with each other. The risk is that a hidden renovation can change the real load path from what the drawings suggest. Good engineering does not pretend that risk disappears. It gives the system margins, feedback, inspection points, and simple habits that let people notice trouble early. When those layers line up, the result feels almost invisible. That is the quiet compliment infrastructure earns when it works. This is why controlled demolition rewards patient attention. A design can be technically correct and still fail if it ignores how people move, wait, carry things, make mistakes, or rush. The best version of the system respects both physics and behavior. It gives force a path, gives people a cue, and gives operators a way to keep improving after the ribbon cutting is over. As you watch the footage, look for the small alignment choices, where motion begins, where people pause, where material changes direction, and where the system leaves room for correction. Why demolition is engineering. Removing a structure safely can be harder than building it because gravity, age, damage, utilities, neighbors, and uncertainty all show up at once. Why demolition is engineering. Removing a structure safely can be harder than building it because gravity, age, damage, utilities, neighbors, and uncertainty all show up at once. In structural demolition engineering, the visible object is only the surface of the system. Under it are choices about load path, center of gravity, column capacity, cut order, collapse radius, blast delay, falling direction, vibration level, dust plume, utility